There was a time in American industry when a serious technician could open a toolbox, a service case, or a bench drawer almost anywhere in the country and find the same object staring back: a black meter, a white scale, a needle. The Simpson 260 was not glamorous, it was not futuristic, it was not even especially fast. But for decades, it was trusted in radio shops, factories, utilities, military depots, laboratories, and aircraft maintenance rooms, with a level of confidence most modern tools never achieve. And that is the paradox at the center of this story. How does a company become so reliable, so familiar, so woven into technical work that its product feels almost universal, and then lose the world it helped define? To understand Simpson, you have to start before Simpson. In the early 20th century, electrical measurement was awkward. Technicians often needed separate tools to check voltage, current, and resistance. Those were the basic quantities of electrical work. Voltage is electrical pressure, current is electrical flow, resistance is opposition to that flow. If you could not measure those three things quickly, diagnosing a fault meant guesswork. In 1920, British engineer Donald McAdie helped solve that problem with the first AVO meter, a portable instrument that combined amperes, volts, and ohms in one box. That idea changed fieldwork forever. It made electrical troubleshooting mobile. It made it practical. And it created the market that Simpson would eventually dominate in America. Ray Simpson entered that world as a builder of precision mechanisms, not as a showman. Simpson Electric traces its prominence to 1927, when Ray Simpson built the indicating mechanism for the earth inductor compass, used by Charles Lindbergh on the Spirit of St. Louis during the first solo transatlantic flight. That was not a small credential. For 33 hours, in one of the most watched flights in modern history, navigation depended in part on an instrument tied to Simpson's work. Before founding his own company, Ray Simpson had also served as president of Joule Instruments from 1922 until it sailed to Weston in 1931. He understood measurement not as a commodity, but as a discipline. A meter was not just a device, it was a promise that a reading meant something. That culture shaped the company from the beginning. Simpson Electric says its roots reach back to 1927, but the company itself was chartered later, in 1936, with advertising and sales beginning in 1937. One trade account suggests the gap may have been the result of a non-compete agreement after the Joule sale. Whether by necessity or design, that delay may have helped define Simpson's temperament. When it entered the market, it did not arrive as a loud consumer brand. It arrived as a maker of industrial instruments, panel meters, test equipment, sensitive mechanisms built for hard use. Its early patented designs focused on sturdy meter movements and alignment, technical details that sound minor until you remember what the product had to do. It had to stay accurate after shipping, after field use, after vibration, after years on a bench. Then came the product that made the company. In 1939, Simpson introduced the Model 260, one of the first high-sensitivity AC/DC volt-ohm millimeters, usually shortened to ohms, to achieve mass popularity in the United States. The name sounds technical, but the idea was simple. One portable instrument could measure volts, ohms, and milliamps. In plain English, it could tell you whether power was present, whether a circuit path was intact, and whether current was flowing in the amount you expected. For a repairman or factory technician, that meant fewer tools, faster diagnosis, and a more systematic way to find failure. The 260 sold for $27. That mattered. It was capable enough for professionals, but affordable enough for service shops and production test benches. One of the reasons the 260 stood out was a phrase that looks obscure today: 20,000 ohms per volt. This was a measure of sensitivity, and sensitivity in an analog meter means how much the meter itself disturbed the circuit it was trying to measure. A low sensitivity meter could load the circuit and bend the result. A higher sensitivity meter interfered less. In plain English, it was a better listener. It drew less energy from the thing being tested, which made its readings more trustworthy. especially in the delicate electronic circuits that were becoming common in radios, communications equipment, and industrial controls. That was the hidden genius of the 260. It was not just portable, it was portable without being crude. It brought lab-like confidence into everyday service work. The early 260 was also a physical object from another age of manufacturing. Surviving documentation for the original model shows a 3-pound instrument in a case roughly 6 by 5 by 3 inches, with hand wiring, soldered-in batteries, and no printed circuit boards. Its July 1939 operating instructions show multiple voltage ranges up to 1000 volts, current ranges from microamps upward, resistance ranges, and decibel scales. This was not a toy for hobbyists. It was a compact field instrument for an electrified society that was becoming more complex by the year. Later versions would add features technicians came to love: mirrored dials to reduce parallax error, tougher cases, better overload protection, safer jacks, and shock-resistant movements. But the core idea was already there in 1939. 1 meter, many jobs, very little wasted motion. The Second World War turned that useful product into a standard. Simpson's own history says the 260 was the first compact all-purpose voltomillimeter, and that thousands of military personnel used it during the war. That detail matters because wartime does more than increase production. It standardizes habits. When the military trains large numbers of technicians on one tool, those people carry that familiarity back into civilian industry. The meter becomes part of a generation's muscle memory. In the 1940s and 1950s, America was full of men who had learned electronics in uniform and then went to work in radio repair, aviation, utilities, broadcasting, factories, and defense plants. A product used in war often returns home with an aura of proof. It has already been tested under consequence. Ray Simpson also expanded with a long view of the place. In 1946, he bought an old school in Lac du Flambeau, Wisconsin, and converted it into a Simpson Electric molding plant. That move was partly practical. Manufacturing growth after the war demanded space and flexibility, but it also foreshadowed the company's unusual future. Ray Simpson had a documented affinity for the Lac du Flambeau area and for the Chippewa residents there. Decades later, that relationship would become central to the company's survival. For the moment, though, the post-war years were an era of expansion. The 260 remained the emblem, but Simpson built a broader reputation in panel meters and test equipment for industrial use. By the middle of the 20th century, the Simpson 260 had become more than a product. It had become a working language. Technicians trusted it because it was readable, durable, and predictable. An analog meter shows change continuously. The needle rises, dips, hesitates, and overshoots. That is useful when you are watching a fluctuating signal, tuning a circuit, or trying to see a trend instead of a frozen number. Even today, Simpson's own 260/68 product page still makes exactly that claim. Nothing beats a 260 for monitoring fluctuating trends and rates. That statement explains why the meter lasted so long. In some tasks, the human eye understands a moving pointer faster than a stream of digits. The 260 did not just measure a circuit, it let a skilled technician feel what the circuit was doing. As the company grew, it scaled into a major industrial employer. In 1959, Simpson Electric, then a division of American Gauge and Machine, took over a large Elgin, Illinois factory complex. By the 1970s, according to the Elgin History Museum, Simpson Electric was the world's largest manufacturer of electronic measuring instruments and test equipment, employing 800 people in Elgin alone. That is the rise in one sentence. A company built around precision mechanisms had become a major manufacturing operation in the American Midwest. It had factory floors, product lines, distribution, and institutional customers. It was no longer merely the maker of a famous meter. It was part of the industrial landscape, and Simpson was not technologically frozen in amber. In the 1960s, the company supplied special two-movement cross-pointer instruments for NASA's Apollo program. A cross-pointer instrument uses two needles at right angles, so an operator can read two variables at once. or see their combined condition on one face. In practical terms, it was a compact way to present critical information where space and clarity mattered. Simpson says 14 different types of these NASA meters were built for spacecraft, ground support equipment, and prime contractors. In the same decade, the company also introduced a line of digital panel meters, explicitly to keep up with technology and customer demand. That point is important. Simpson saw the future coming. It was not ignorant of electronics. It was not trapped in the 1930s. But seeing a shift is not the same as winning it. By then, the 260 had become a legend. One trade history says well over 5 million Simpson 260 meters had been sold, possibly more, and calls it the most popular analog meter of all time. That estimate is hard to separate from nostalgia, but the broader point is clear. The 260 was everywhere because it solved an everyday problem better than its rivals. It had wide ranges, it was accurate enough for real work, it was rugged, it was familiar, accessories and service information stayed available, even used units remained repairable because parts, schematics, and donor meters could still be found. This created an ecosystem of trust. A technician did not just buy a meter, he bought into continuity. The instrument could stay on a bench for decades and still make sense to the next person who picked it up. Then the market moved under Simpson's feet. The decline of the analog multimeter was not caused by one blunder or one bad executive decision. It was caused by a deeper shift in what technicians increasingly valued. Digital multimeters offered numerical readouts that were easier to interpret at a glance, higher accuracy, and much higher input impedance. Input impedance is the modern version of the earlier sensitivity story. The higher it is, the less the meter disturbs the circuit. Digital designs also became smaller, lighter, and eventually safer. They could add features analog meters could not easily match. Auto-ranging, min-mams capture, data logging, later, computer connectivity. The old analog needle still had strengths, but the center of gravity in the market was changing from feel to precision, from motion to digits bias. The pivotal commercial signal arrived in 1977. That was the year Fluke introduced the 8020A, described by Fluke as the first successful handheld digital multimeter. It sold for $169, delivered accuracy of around 0.25% of reading, ran for roughly 200 hours on a 9-volt battery, and sold more than 250,000 units before its retirement in 1984. By the end of the decade, Fluke says the broader 8020 family had reached 1 million units. Those numbers matter because they show the new standard being born in real time. The handheld meter was no longer simply a rugged analog interpreter of circuits. It was becoming a compact digital computer for field diagnostics. Once that happened, the 260's greatest virtue, its mature analog excellence, became a narrowing specialty rather than the default future of the industry. Simpson did not disappear overnight. It kept building products. It had already moved into digital panel meters in the 1960s. It remained respected in industrial instrumentation, but scale and relevance are different things. A company can still make good products while losing the mainstream category that once defined it. The 260 could still outperform digital meters in certain kinds of trend watching. Some technicians still preferred it for tuning and for reading unstable signals, but preference is not the same as market leadership. If you enjoyed this documentary, subscribe for more stories about the tools, companies, and inventions that built the modern world.